And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.
Okay, hey guys, we're live. This is Creation Discussion 4. It's a chat with Speed of Sound. This is just going to be a back and forth discussion for about an hour or so. The topic is mostly going to be over creation and evolution, and we're just going to start off with both telling a little bit about ourselves. So, Speed of Sound, if you want to go ahead, you can just give an intro.
Okay. Well, let's see. I decided I'm a presuppositional naturalist and a hard atheist, and got into genetics a couple of years ago and biology, and really enjoying it. And I'm just really interested in the creationist mindset. And so I've been listening to a lot of your videos and participating in a few hangouts, and that's about all I got.
Okay. I'll tell a little bit about myself. I am a Christian. I've been interested in the creation evolution debate for coming up on 6 years now, because I think about 2014 was really when I started picking up on it. I'm mostly interested in studying intelligence in like organisms. I'm also like to look into the topic of kinds and speciation, and that's about it for me. This is you're the first atheist that I've had on my channel, so everybody else in the same like young Earth crew. So it's good to have someone
Okay.
else with an opposing view on. So
Yes, opposing it is. So,
so, but did you have any questions for me or?
how long have you been a young Earth creationist?
Well, see, interestingly though, I was not brought up a younger creationist, which is it's kind of an outlier, I guess, compared to a lot of other people that kind of grew up with it. I was brought up, in an old Earth view where we believe that pretty much God just created over billions of years. My family is still they're kind of agnostic in that area. I don't really think they're kind of in between maybe young Earth and old Earth, but they don't accept evolution, but they may be open to accepting an old Earth. I kind of became a young Earth creationist, I guess, about 5 or 6 years ago. Maybe is when kind of because for a while I was just kind of like how my family is now. I was just kind of it wasn't really that important to me. I guess I kind of just. I mean, I didn't really. I guess some ways I wasn't as interested in the age of the Earth compared to the other evidence. But I thought that the young Earth does seem to fit better with reading the scripture, and that kind of led me to become a young Earth creationist.
So, what was there ever a point where you accepted evolution, common ancestry?
No, I have not. I've never accepted. I mean, I accept limited common ancestry, but there was never a point where I did accept evolution. But the main thing is just we believed, even like early on, that when I was reading books on dinosaurs and whatnot, all the prehistoric stuff, my view as a kid was just that God had created life over millions or billions of years, and it was like it's kind of similar to like progressive creation. But one interesting thing though is that I wanted to add is that my family, even though we were in me, even though I was an older creationist, I still accepted like a global flood, which I know these days a lot of older creationists don't do that. Yeah, I've never actually accepted evolution as in like universal common descent.
Okay, what do you think your biggest problem is with evolution? What doesn't make sense?
Let's see, that's kind of a tricky question. I think some of it has to do with me questioning the mechanism and whether or not it can happen to the extent that they say it did over time. I am skeptical of that. Oh, I see your cat there.
Yeah, my cat wanted to be alive, so I
Oh,
turned the
okay.
camera on. Yeah, now he's gone. He just wanted to say hi.
Oh,
He's actually an evolutionist.
oh, really?
Yeah, yeah.
But yeah, I question the mechanism and whether or not it can actually happen the way they say it did. I I guess that would be the main issue. I also think that maybe some issues with the tree of life that may contradict things a little bit. There was a source that I can send you later. I didn't even think I was going to bring it up until now, but it was kind of describing like a top down evolution instead of bottom up evolution, and that like the genes for a lot of the plans are already in place. Like way before any of that stuff evolved. And I think that to me, if that's the case, that would just indicate that there's some kind of foresight or something was pre-planned. But it's a source. I will send it to you when I get the chance.
Okay, I'll take a look at that. I think what really clinched it for me was looking, not so much looking at human evolution or the animals as we know them, the zoo animal evolution, that part, but looking at embryology and how a single cell develops, and basically looking at it from the standpoint of molecular biology. And I'm going to cough again.
Okay.
Getting over a cold. And I realized kind of when I went into that I was very skeptical about how in the hell could this thing have evolved by a statement. You guys love the phrase random chance. I never did like that particularly, but I mean, I had questions about how a bunch of molecules knocking together could possibly create these proteins in these machines. And the further I looked into morphogenesis or embryology, the more the stronger my conviction became, that it happened that it all came together naturally. And it's and I think Standing for Truth likes to talk about SpongeBob imagination, and I don't know what the hell's wrong with imagination. You learn something, like you learn chemistry, and I have a long background in chemistry going back to when I was 10 years old. You learn chemistry, and then you use your imagination to apply that or to figure out what is happening, that sort of thing. And molecular biology is the same. The more you learn, the more you can fit these little puzzle pieces together, and you can see how it could have developed naturally. So it has really confirmed evolution for me. Not so much common descent is kind of a red herring, sort of. I'm not sure if it was all that common. I think there were 3 billion years of those little microbes floating around, bumping into each other before we ended up with a eukaryotic cell. And that 3 billion years was an incredible experiment in complexity. And that's kind of where I think most of it happened, at least most of the systems that we look at today. When you look at a eukaryotic cell and you see all these wonderful machines, all of that happened in that soup with those single-celled animals before it became multicellular. And so anyway, that's kind of my take on it. The more I read, the more convinced I become.
Okay. I guess my take mainly on abiogenesis and evolution is it seems to me that the evidence suggests that it'd be hard for life to get started the way because I've kind of got a mixed response from people when I ask them about the origin of life. Some of them, talk about how easy it was, and then some people are saying, no, we don't know. And I'm talking about, people that believe evolution. One interesting thing, though, that I brought up in the presentation. I was looking at my notes here that see some of the stuff that makes me skeptical of evolution, of how it could have happened naturalistically and not without some kind of intervention, is kind of the level of intricacy that arose pretty quickly. Like I was saying, that they say maybe the oldest possible life is about 4 billion years old, an older scenario, and they were saying that they already had the ability to use photosynthesis. And I am just skeptical of whether or not that could have arose under naturalistic circumstances, when I don't think that life could even get started on its own. I don't think that it doesn't seem like there's much of a mechanism for it. And that's my take on it.
Yeah, I can understand that view. I found, I think I have 3 or 4 books that I read recently that I think I read maybe 1 or 2 of them. I need to read the other ones, but they get into all the possible scenarios for abiogenesis. And abiogenesis is a devil. I mean, we're trying to figure out what happened 3 billion years ago on a planet that we don't quite know even what the atmosphere was for sure.
Yeah.
We have some guesses. And the most convincing things that I ran into, I forget the names of the authors, were things about those volcanic vents and different energy systems. And it was an energy first sort of scenario. And the more I read about that, the more convinced again I became that it's possible. And we ended up with these. The biggest problem I have right now is trying to figure out how the lipid bilayer of the cell formed, how those chemicals were manufactured, and how we ended up with cells at all. And
yeah,
this is, we're trying to figure out a great mystery that happened 3 billion years ago. And it isn't easy. Of course, you don't believe there was 3 billion years ago.
Well, see, it kind of relates to something I saw. It was an article I saw on, it was the Intelligence Discovery Institute. And it was kind of reminds me, this discussion kind of makes me think of that. It was a professor, it was a physicist. I believe he's a physicist. He said that, let me see if I can find the quote again. I'm going to search evolution news. I want to make sure I read it correctly. If I can't find it in a few minutes, I'll just paraphrase. I don't know what the name of the article was. Just trying to. Okay, here we go. It says physicist Brian Miller. It says 2 conundrums for strictly materialist views of biology. I can send you the link in the chat if you'd like me to.
Sure. Yeah.
Okay, hold on. Let me send you the link in the private chat. There we go. And he said he had 2.
Nobody's watching us. That's cool.
For me, it shows that there's 2 watching.
Yeah.
I guess, I don't know.
And you? I think I'm one of them. So.
Maybe, I think Standing for Truth might be watching too. But yeah, I'll read the. Go ahead.
I'm going to give him hell. So it's good that he's watching. Why can't I find it?
Are you looking at the? There's a private chat bar on the.
Yeah, I
right
found
side.
that.
Okay.
Oh, I was using my Windows system today, so I'm typing in Control V instead of Alt V or Command V. I go back and forth between a Windows and a Mac, and I get confused because I'm old and confused. Intelligent. Okay, this is physicist Brian Miller. Okay, I'll have to take a look at that. Okay, so what was the quote?
Well, I'll read there's 2 quotes. I'll read the second one is the more relevant to the discussion, but the first one is, he says, all mutations which have been observed, which are non-harmful, only allow for small-scale change, while all mutations which could potentially change the architecture of an organism have been shown to be harmful. And the second quote was, he said, nothing in nature will ever simultaneously go to both low entropy and high energy at the same time. He says it's a physical impossibility, yet life had to do that. Life had to take simple chemicals and go to a state of high energy and of low entropy. He said again, that's a physical impossibility.
Yeah, and I just don't understand what the hell he's talking about. I heard that quote before. And, well, abiogenesis is something that we probably don't want to get into, but basically there was there was a lot of energy. It was a very, very hot world, or a very hot place. And so there was a great deal of energy, and there were systems, and there was had a lot to do with hydrogen ions and hydrogen pumps and things like that. And the complexity in basically when you have a system with a lot of uh, energy, it builds complexity, and that's what happens. And we've seen that happen in the laboratory. I mean, that does happen. We build organic molecules with energy in it. So I don't quite understand where he's going with that second quote. The first one about mutations and how now if we skip ahead from abiogenesis back to the beginning of multicellular animals to where there are eukaryotes, that's something that I can address, or I'd be more comfortable addressing. This other stuff I would, maybe in a year I'll get into abiogenesis, but right now it's kind of where I live. All mutations which have been observed, which are non-harmful, only allow for small scale change. Now, the thing about mutations and the problem I have with genetic entropy in general is proteins fold. Do you know anything about protein folding and the shapes that they take, like alpha helices and beta sheets?
I do know a little bit about it. Yes, it's not my specialty, but
it's kind of I keep this little toy around. Let's see if I can get it in the camera. It's sort of a magnetic thing.
oh yeah,
play with, right? And proteins are kind of like that. And there's the amino acids. There are 8 of them that are hydrophobic. They don't like water. There are 8 of them that are polar. They do like water. And then there's 4 that are charged, and they're actually, they have a little bit of magnetism to them. And it's kind of interesting that the 20 proteins or 20 amino acids that life chose, or that life selected, ended up in this wonderful balance, this 8-4-8, and when there's a mutation, a lot of mutations, like 20 to 30% of them, I think, when I ran some models, don't do anything at all, because the codon is redundant. So that means that you can have a mutation and it's going to still select the same amino acid. So those don't have any effect at all. Somebody's going to nail me on that. There's one way in which they have an effect, but that's getting overcomplicated, so I won't address that. But so we have these. They're called synonymous mutations, or they're completely neutral. They don't do anything. And then there's other mutations that happen, like if they happen to the protein itself, to the protein coding part. A lot of mutations aren't going to make any difference at all in how the protein works. There are all these alpha helices and these beta sheets, and they form sort of a holder for whatever it is that they're operating on them. And then there's a little tight cluster of amino acids that makes up the domain that actually does the work. And I don't know if you want to get this in depth on it, but there are for any particular reaction that you want to do with proteins, if you look at a protein that has 200 amino acids, it has 20 to the 200th power possible structures. And out of those possible structures, an unbelievably large proportion of them will do the same function. So anyway, there's so when a protein mutates, okay, if it mutates and it screws up the function, and that function is vital for the organism will die unless it has another copy of it somewhere. And mutations for the most part don't have too big an effect on us. Life sort of happens anyway. And then if you end up with say a gene copies itself into another area of the genome, and it starts to mutate and it starts to be expressed in some manner, and there's a whole lot of different ways that it can become biochemically active. And if it becomes biochemically active, it's going to do one of two things. It's either going to affect the biochemistry of that cell, or it's going to affect the shape of that organism, depending on which gene it is. And so from that standpoint, mutations, even small mutations, can make very big changes in that structure. Sometimes most of the time, they don't do anything harmful at all or anything noticeable at all. Every now and then, they will make an entirely different kind of protein or a different tool, and that tool is out there. and it's sitting there. And if you have a selection pressure that brings it into play, then that will be part of life. Lenski's bacteria has shown a little bit of that. And if you look into what really happened with those bacteria, it's kind of interesting how they kept adapting by mutating.
Well, see, it actually kind of relates to one of the things I said in my presentation, which to me, it was a thing about how bacteria could, when they were struggling and they had, were in a tough spot, they could mutate, give themselves mutations to try to gain new abilities. But they had said, the article had said that it was actually, a lot of the time, it was kind of like a last ditch effort. It wasn't like something they would just do, just whenever they wanted to. It was so a lot of times the mutations would be harmful. And I think that's kind of, for one, I think that shows that there's some kind of built-in mechanism for them to know what to do and how to adapt. And I also believe that it shows that mutations, that they can try that, but a lot of the times, if not most of the time, it will be harmful, and they may end up suffering for it. And
Okay.
I just think that mutations, with the way that they break, as deleterious as they can be, and so much of, I just question whether or not that could lead to that can result, I guess you could say, from into all the life we have today. I don't believe it can really do anything more than minor variation. It makes me reminds me of this quote. Let me find it here. Let me find her. It was an old biologist named Lynn Margulis, and she was kind of critical of, I guess, natural selection, and I guess the limits of maybe mutations. Let me find the
She had her whole thing was that symbiosis had more to do with evolution than anything else, and she was like spot on when it came to how mitochondria developed and how chloroplasts developed. And there was a lot of pushback against her because she was very outspoken. She would tell you, what the hell did she say? Something about I don't know. She said basically, but I'm right, And
so I don't think she was treated fairly.
Well, for one thing, women weren't treated fairly very, very much in the 20th century. And for another thing, she was very, very outspoken and very eccentric. And she had some eccentric ideas, and a lot of them I agree with, and a lot of them I don't. And she was trying to make a case for why symbiosis had more to do with evolution than just natural selection. She kind of had a thing for it. And I'm a little more balanced in that. I think all of those things are in play: genetic drift, natural selection, neutral mutation theory, chimera. And the whole thing is so complicated. It's just a mess. What I'm seeing coming out of the Creation Institute is sort of makes me sad. There's all these mathematical models that we have. All of them are extremely simplified, and they're meant to show one thing, one little part of the whole piece. But when it comes to life, it's not that damn simple. It is all of these models together. If we were to mathematically model what happened in life, we would need a computer larger than the universe to model the damn thing. And that's kind of what we're up against. But yeah, I'm familiar with Lynn Margulis, and she's a very interesting character. I wouldn't take little quotes out of context because she basically, she believed in evolution.
I agree. I'm just saying, I was just going to relate that to how she was questioning the how that particular mechanism could work like it did.
Well, yeah, everybody's questioning it. I mean, everybody's questioning what part natural selection plays in all of this. And
I'm trying to find the source that I mentioned earlier. I can't find it now.
I think I had that up recently.
Or not the one with Lynn Margulis. It was one that I was talking about. There's relation to what we're talking about with the mechanisms. It was the thing about bottom-up evolution. I'm trying to see what that I'm trying to see where that was. That's one of those sources that I can't find necessarily, but just right off the top of my head, it's one of those things you have to look for. I guess I can just send it to you after the chat. I can send it to you in an email. I can't. I'm trying to find the link.
Yeah.
I don't know if maybe it's the wrong site I'm looking at. Someone's wanting to join the chat. I see.
Yeah.
But yeah, I guess this will just be me and you for this one because that's kind of what we planned. So if they want to do something in the future, we can.
Who wants to join?
Who wants to join? Says Alex. I'm not familiar with who that is.
I don't know who that is either.
Yeah,
I'm afraid of too many creationists at the same time.
Yeah, I can't. So I'm trying to see. I don't know if I can even find that link, but whatever. I'll find it to after the discussion. And I'll just send it to you.
Yep.
Let me look at the notes and see if there's anything else I'd want to cover I don't want us to forget something. Okay, this is one thing we haven't necessarily talked about yet. I know that you saw the presentation that I did, and this is one of the main topics. I had listed a few that I wanted to go over, and I don't think we've talked about this one too much yet. I don't want us to get off, not end up talking about it. What was your opinion on the presentation? Because I've gotten a kind of mixed response from
which one?
The one with the it says intelligence and microorganisms.
Yeah, it was pretty cool. It's just that I guess, why does that surprise you?
Well, because to me, I mean, even like some of the people I've talked with have been like, well, how can they be intelligent? They don't have or how can they show any intelligent adaptability because they don't have a nervous system. That's one of the responses I've got. It's just, and they don't seem. It just seems like the more we discover, that's what we would expect to see if there was an intelligent agent behind it. It's not the God of the gaps argument I'm making. It's just that I am saying that that's the best explanation is that it's likely that intelligent design was behind it in the terms of the argument.
Okay.
And I just have gotten the main reason I did the discussion or the presentation, I'm sorry, was that I didn't think that was really well-known evidence to a lot of people. It was like I said, some of the several of them at least were atheists or they advocates of evolution, and they had said they didn't really. I don't think they really knew about it. I don't think a lot of creationists knew about it, and I thought that was a very good piece of evidence for creation. And that's kind of what led me to do the presentation on it. I mean, I don't think. I mean, do you agree that there is like this intricacy there? Because I know that some in the past have said like, no, they don't really acknowledge that.
Yeah, and that's okay. There's this rhetoric that I hear, and I'm going to dig standing for truth. Like he'll say that, oh, evolutionists don't want to talk about epigenetics, or they don't want to acknowledge this or acknowledge that. No, biologists are aware of all this intricacy, and I'm sure that microbiologists are quite aware of the amount of intelligence there's. But I guess the surprise in the papers that you read was that that basically the organism runs into a situation and it learns from it. That it actually makes a permanent change in the organism. But then, if anybody knows anything about epigenetics or just the way molecular biology works and the way proteins work and signaling mechanisms work, it is not a surprise that they would learn from it, that they would have some adaptability. And especially, you got to remember that parameciums and rotifers have been evolving for 3 billion years alongside of us. So, I mean, there's quite a bit going on with them too. And that's what I mean. But there's this vast array in genomes, not so much in well, I guess in the eukaryotes. There's this. The genomes range in size by orders of magnitude. I mean, there are very small organisms that have large genomes, and there's a certain percentage of it, like in some of them it'd be like 5 or 10% that's actually vital. And then there's all this and I don't want to call it junk DNA, but there's this whole warehouse full of proteins that are mutating away and developing and creating new tricks. Now, if you suppose you were a machinist and you had this huge garage, probably the size of Menards, the size of Menards in the movie Idiocracy, where it went over the horizon. I don't know if you saw that or not, but anyway, they were making a joke, I think, about Menards, and it went over. It actually went over the horizon. It was that big. It was gigantic. But anyway, you had this huge warehouse, and in the warehouse you had all of these holders for holding your work, that you were going to work on. There were all these different holders, and then you had all these different tools that you could plug into the holder, so that you could put a piece of metal in the holder, and then you could bring in a bit or a drill or something and operate on it. And that's what all these proteins churning around are doing. They all have the potential to be biochemically active. And when two of them lock together and form some sort of a mechanism that does something, then that infers an advantage to that organism. And there are 10 to the 40th microorganisms out there on just the surface of the ocean right now, knocking about, trying out different things. And each of them have they have this gigantic warehouse of tools. And all of these things are knocking about. And it isn't surprising to me that occasionally they knock together and form something valuable. And of course, you have to add to the metaphor that when you leave your garage at night, your garage mutates, your tools mutate. So when you get there in the morning, you have the tools that you need, that you want, that you use every day, which would be the vital ones. Then you have all these mutated tools, which don't mean anything to you until you need one.
See, a lot of my okay. Am I unmuted? Okay, I muted myself for a second.
Okay.
Well, see, one of the issues I have is that a lot of this just seems kind of speculative, because a lot of the farther we go back, we do see a lot of this stuff. Some of it just seems to appear pretty instantaneously, and a lot of the cyanobacteria, for instance, they you go back the 3.7 to 4 billion years of what is that range. A lot of that they were when you see them in the fossil record, they already have all these features, and it just seems speculative to say this evolved a certain way or not, because it just seems like it's kind of like, well, we don't know, therefore we're just trying to say that it happened this way, but I don't really know if that's a very adequate explanation, or I don't think it's adequate, because there just seems to be a degree of speculation and just, in my opinion, wishful thinking, because it's not really. I don't think a lot of it's based on hands-on evidence. I think that's kind of the problem I have.
Well, the hands-on evidence is what molecules do, and that's where I mentioned embryology and morphogenesis. Like if you look at how a single zygote, turns into an organism. God, I think I want to go back to something first before I get into that, and that is the intelligence of those microorganisms that you were talking about. Now, I think one of the quotes you had said that they think, which is quite a stretch. But how do you think that intelligence happens? Do you think that happens by God's hand, or do you think that is being currently intelligently manipulated, or do you think that is chemistry?
Well, I mean, I think it's a little bit of it being something that's constantly going, and it's something that was programmed by God in the beginning. But I think that, I mean, when I say that they adapt and learn, I mean, that's something that is not, like, how we learn. I mean, that's an ongoing thing. But the initial, um, built, like the mechanisms themselves, I believe, that was there programmed at the beginning.
But you don't think that God's fingers are in there manipulating that intelligence today. You think that it was programmed in the beginning, right?
Well, it's kind of like, try
So
to
it's
use an
chemistry.
analogy.
Chemistry now.
Well, more like adaptability and, I guess, adaptation and, learning from what's going on, similar to how we would adapt and learn what's going on. Now, I'm not saying chemistry is not involved, but I don't think that's necessarily every bit of it. I mean, I think there is some, level of built-in intricacy that um, is kind of at the foundation of everything.
Okay, but what is that foundation made of?
It's made of, what everything else is made of.
Chemicals?
Yeah, I mean,
Molecules.
I'm not saying that there's no chemistry involved. I'm saying that was the mechanisms were there, and the learning is what's just goes on and on.
But the mechanism was basically created with chemicals, and it is chemicals at the beginning of the day. When the organism goes out to learn something, there is no intervention. There's no intelligent intervention from 6 a.m. until lunchtime when he actually learns something, right?
Well, I mean, that's not what I never really made I never made the claim that that's what happens.
Okay.
I never said that God is just constantly interfering with everything. I mean, that's not. I don't think any creationist would say that God is just intervening at every little point in time and somewhere. I mean, the main thing is that, I mean, that's just not what we're saying.
Okay, good, because I'm glad you aren't, because that would be because I would have no counter to that. I mean, if you were saying that basically it was an ongoing manipulation.
Well, you were thinking that I was. Did you think that I was?
No, I'm
Okay.
not accusing you of that. I'm just trying to walk you through it and get down to the level that I'm thinking about it. And like, it's the same thing when a single cell, big, what looks like a bag of water to us, it's not actually a bag of water, a zygote, turns into a complete human being. It's the same thing. There's no intelligent design from that single cell point to the human being point. It's all chemistry, right? It's all molecular biology from there. So you already believe, I mean, you're already putting a whole lot of faith in molecular biology if you believe a single cell can develop into a human being without intelligent intervention, correct?
Well, I mean, it's just, I don't think that it's really. It seems like it's maybe a misunderstanding of what I'm saying. I mean, I'm not saying that God is just constantly intervening, like in the. It's like someone that builds a computer and the computer runs on its own. And I mean, he initially built the computer. I mean, I'm not saying that God is just constantly intervening at every turn, trying to intelligently design this and that. I mean, I'm saying that you could compare it to like someone with a machine. I mean, they build the machine and the machine does what it's supposed to. But I mean, I'm not sure if exactly. Are you saying that? What was your point again?
Okay, my point is not that you did this or that you think this way. My point is that you're not thinking it through. You're not looking at what happens currently. Like when you say we're speculating about the past, or we're making, we have just so stories about what happened in the past and all that. I'm talking about what we know, what we can observe happening in the present. And we can observe a little bag of water, a single cell turning into a human being.
But see, I don't really know what that
All
has
with
to do though
chemistry.
with. I don't see though what that has to do with the origin of life and universal common descent. It just seems like two different things, because the cell is programmed to turn into the zygote is programmed to turn into a human, but the origin of life process is, random mutation, natural selection over millions of years. That's not a programmed thing. If that's what you were, it just seems like it's just two different things altogether.
Okay, it's programmed, or I would not say it that way, but you believe it's programmed, but it's programmed with molecules, and it's executed, it's enacted with chemistry, with molecular biology. See, if you believe in evolution, then you believe in this wondrous, unbelievable, universe-sized complexity of molecules. But if you believe in biology as you do, and I'm not accusing you of believing that God's hands are in that creation, transformation from the embryo to the human. I'm saying that if you believe in that, you're also believing in a whole lot of chemistry, a whole lot of molecular complexity that's possible. I mean, even if you believe that the DNA is some sort of magical code that that somebody programmed to get from that DNA to a full-size organism, it's quite a miracle in itself. Don't you agree that that's a miracle in itself?
Well, I mean, I think it is amazing, testament to God. I think that I would say that it's a very remarkable thing. I think it's something that's just, I think that we should pretty much be in awe in that, this something like this it works like it does. It is very interesting thing.
I'm going to try to pick this up, but I love this little thing. This is a protein. It's a very small one, but it's basically they twist around, that sort of thing. You see these black things? They're carbon atoms. And most of the magic I learned about when I was, I think, 10 years old. I read a book called World of Carbon by Isaac Asimov. And just the way that carbon combines creates that miracle that turns that zygote into an organism. Now, it is the same miracle that evolution is made of. There's no difference. So when you say that we're making stuff up, we're not. We're looking at what's happening now to genes and molecules. We're watching them mutate. We're watching new proteins form and be transcribed. We're not watching new machines in the process of creating. There's nothing we're making up. We are projecting back, and of course, everybody's trying to guess. What are we related to, or what did we come from, or what was that thing that basically crawled out of the water the first time? I mean, that is all. You might say speculative, but it's not even speculative because scientists work very hard on these fossils. But I mean, we're just extending what we know about molecular biology today into the past and trying to figure out what the path was. Now,
I wanted to bring up really quick what you mentioned a few minutes ago. Like, my point is that I don't think that you're saying because something is happens with this program to do something that necessarily means that evolution by random mutation, natural selection can result in all that we have today. I don't think that that's necessarily a good comparison. I think because compare a butterfly, for instance. They have their whole in their genetic codes all the instructions for they hatch and they build a cocoon, they transform into butterfly. But see, I mean, that's not something that's just like a program process. And saying that all these random mutations pop up and lead to all this new behavior or new information, I just don't think that they just seem like two different things altogether.
Yeah, and that's the DNA as information. If you believe in DNA as information, then that's where you go off the path, because it's no more information than a riverbed is information to the water flowing through it.
Well, I don't know how it's not information. I mean, all of the instructions for everything in our bodies, everything we do is coded in the DNA. So I don't know how you couldn't say there's not information.
They're not blueprints. They're not instructions. They are molecules. And when other molecules bump into them in a certain way, something happens. And that's a level that you look at when you get into molecular biology. You start seeing how they, these, basically it's not information. We can think of it. We humans like to think of tools and information and communication and all of that, but you're anthropomorphizing something that doesn't work that way. Now, one of the big things I've heard on your channels, all of you, is how, scientists discovered this new thing. DNA reads backwards and forms RNAs that do other regulatory things. And ERVs are found to have a function, and DNA works this way and now it works this way. I mean, there's all this complexity. Every day, thousands of papers are being written on some new way that molecule interacts. And that is not the same as a blueprint. When you read a blueprint, when you read information, you read it one way according to one codec, and that's it. But that's not what happens in the cell. The cell is like exceedingly more complex than that. And all of these new things that we're discovering, all these new forms of regulation on DNA, are just testament to the fact that this is spaghetti code. It's not programming code. It's not good computer code. It's the wonder of the complexity of the carbon atom and what it combines with. That's kind of what I see.
Well, see, I mean, even if I were, to say, look at things through your eyes and say, you don't believe that it's programmed, but it's hard to think of any other term really besides, you could say maybe natural blueprint or natural instructions, because that information is there, and that's how, that's what's expressed. I just don't see how you can escape it, calling it some kind of blueprint or calling it instructions, like, for instance, the butterfly. How is, if that's, the DNA just, how is that, would that even it be able to do that without instructions coded in the DNA or the information in the DNA?
Well, if you look at the beginning of the butterfly, the very beginning of the butterfly, and there's something else I want to say about life in general if I get a chance later, but very beginning of the butterfly, you have a single cell that's been fertilized, a zygote. And it's just a big empty bag of, proteins. And these proteins from the mother are laid out in a gradient. And because one protein is more present at the top and the other one at the bottom, we end up with the posterior, the head, and the butt of the organism, of the butterfly. That's the first thing that happens. The anterior, posterior kind of segments. And then the cells will start to do something else. And then you can watch them. And at each stage, they're decoding maybe 20, 30 genes, that are creating proteins, and they're lining up and they're creating something else.
But yeah, that's just, you just said like they're decoding. So, they are reading. It is like instructions.
Well, yeah, we can, and we're stuck with thinking that way because, there is the three codon code, that we use to figure this stuff out. But it's all molecules in the end. Like in bacteria, some of the codons are different than they are in eukaryotes. There are a few exceptions. Even in mitochondria, there are a few codons that are different. So it's not strictly a code that you can count on. It just ends up being what worked. That's sort of. But the thing I kind of want you to visualize is how this very simple bag of water starts to turn into a more complicated form. And if you look at that, if you modify just one or two of those little codons, you can end up with a different size jaw, or you can end up, instead of one heart ventricle, you can end up with 3 or 4. You can end up with different folds. And it's just, if you do anything, if you study anything at all, study morphogenesis and embryology, and get into it a little bit and look at the absolute miracle of chemistry and how it creates that, and how very, very small changes can lead to very large changes in the organism. And I think I have kind of a pet theory, and I'm probably all wet, but the Cambrian explosion was a time when there wasn't what they call assortative sexual selection. So there was like great upheaval for 20, 30 million years. And all of these different body plans were being tried out, were, these random mutating body plans, these different morphologies were being set up in all these embryos, and they went off, and some of them were 99.9% of them didn't work. And the 0.1% that worked ended up being part of a body plan. And in the end, we ended up with like 4 body plans, and vertebrates were one of them, or what turned into vertebrates. But I mean, when you look at it from the standpoint of molecular complexity, if you just look at what's happening, what we can observe in a cell now, you can see how miraculous this whole thing is, how miraculous life is, the fact that it happens without any intelligent intervention.
Well, I mean, I agree that it's miraculous, but I'm just skeptical if there was no intelligent intervention that was required to get it actually started to begin with, or to whenever the initial creation.
Yeah, and that's a leap, and I'm not sure if anybody knows. Being a presuppositional naturalist, I cannot imagine a mind or an intelligence that doesn't have a human-like body, mind, and world, or brain and world. So I'm kind of stuck with figuring out how it happened naturally. So I have to use my SpongeBob imagination to work out all of these little mechanisms, and that's kind of what I work on. Everything I learn, everything I program, the models I program, and all of that are to try to figure that out. And I'm doing it with some skepticism. I mean, I listen to you guys and I think, wow, maybe these, I don't want to use a derogative word, maybe they're right. I mean, I consider it for 5 minutes every day that, well, maybe there's an Adam and Eve. And then I can try to figure out, how would that work? That sort of thing. And then I say, nah, it's ridiculous. It's not pretty enough for me. Life, the idea, like a long time ago, I entered a Christian forum and pretended I was a Christian for a while until it got to me. But I was trying to talk to him about, the idea of God zapping everything instantly into existence, or the idea of God being a poet, or a painter, or like Van Gogh, this very creative entity that decided he was going to create this game, or this this hot little ball of matter that was going to blow up and become all of this all by itself. Now, extrapolate that from the Big Bang to what I said about the zygote today turning into a human being in 9 months, that sort of thing. It's the same thing. It starts out as this very simple system, and it complexifies. And there's a whole lot of work being done in biology today, where it's in the last 20 years, and also in philosophy of neuroscience, that involves complexity and chaos theory, and that basically the mathematics of tornadoes and hurricanes and weather systems and biological systems as this self-creating complexity. And I love that. I think that's beautiful. I consider myself a very spiritual person, and that is my spirituality. It's in that complexity, in that miracle of physicality.
I finally found that article I was talking about. It took forever for me to find that thing. It was just not wanting to. Let me skim through this. I'm going to see if there's anything I can quote. If not, I'll just send it to you.
Okay.
Basically, it was talking about. Yeah, it would just take me too long probably to quote this right now, because it is pretty long. But I will. I'll read a little bit of it, because I do want to mention it. I think it's an interesting thing. It was let's see. It was talking about how it says, for more than a century, biologists have assumed that different types of animals were genetically construed or constructed in completely different ways, contrary to the explanations of many biologists. Most of the genes first identified as governing major aspects of fruit fly body organization were found to have exact counterparts that do the same thing in most animals, including ourselves, and says the prevailing view of the architects and adherents to modern synthesis was that the process of random mutation, natural selection, was so altered DNA protein sequences that only closely related species would bear homologous genes. Virtually everything I've described has been discovered in the past 20 years. They have forced biologists to rethink completely their picture of how forms evolve. And then it says, the surprising message from Evo Devo is all the genes for building large, complex animal bodies long predated the appearance of those bodies in the Cambrian explosion. The genetic potential was in place for at least 50 million years, and probably a fair bit longer before large, complex forms emerged. And it says it does not appear that scarcities of the fall of the fossil record without confirmed body fossils, paleontology, they're reluctant to conjure up more than a vague image of featureless worm-like creatures. I believe this is saying that the information for this type of what happened was present in the beginning, and then it kind of refers to what I was saying, the top-down evolution, where there's information, and then it took off on its own, like it was programmed information. I will send you the whole article because it is long. I didn't even think about even presenting that until we started discussing things.
That I agree with them entirely on that, and that's the part that convinces me. The homology in like the Hox genes and the body plans, and how almost the entire story of evolution was over when the eukaryotes were started, right before multicellularity. And that is the amazing thing. I mean, these genes go way back, and it was that 3 billion years of soup, which we are going to have a hell of a time figuring out because there are no fossils. And a lot of these systems, like for single cells to become multicellular, there are these proteins that stick through the membrane. Those things that don't like water, they stick in that lipid bilayer of the cell wall, and they signal other cells. And those are the things that are making your paramecia intelligent. They're receiving signals from the outside world. Well, these things also have the capability, when I think cadherins are the proteins that are primarily involved in cells sticking together. And when they started to mutate, like where one cadherin would stick to another one, but it wouldn't stick it would stick to A, but not to B. These things were all present in that protozoic soup. And these things started to basically cluster together and found advantage in clusters, and the whole show started. But I mean, a lot of the genes are already in place. A lot of the proteome complexity was already there.
Well, see, that's kind of what I mean. It just seems awfully convenient to me, and this is what the type of stuff we would expect, though. If some intelligent agent was involved, we would expect the genes to be in place, and then it diversifies over time. It would be like that would be what we'd expect instead of bottom up evolution, where it just everything evolves, information evolves, from the bottom up. There's this paleontologist who described, how the fossil record has also kind of relates to the genetics. Just talking about how the fossil record shows this, top-down evolution where everything is in place, like the animal groups. I guess you could say the information is in place. Then it diversified instead of it building itself up. So to me, that's something that seems very convenient. I think that is what we would expect to see if there was a designer. I don't think that it would be as much like that if it happened just completely naturalistically. It just seems like there is some bit of foresight and planning there, because it does seem a little bit convenient to me.
I see it just the opposite. There's and again, I'm looking at it from the standpoint of this great complexity. I mean, there was, God, I'm gonna cough. There was this, hang on, damn cold. There was this remarkable, I mean, the things that ended up becoming the eukaryotic cell, those were like 1 in 10 to the 30th different possible things that could have become complex life. I mean, there was so much of it going on that it had to hit upon the right solution eventually.
Hold on 1 second. Let me I'm gonna send you that link. I'm gonna go ahead and do it before. Actually, the link comes from a.
I think I'm dying.
I hope not.
Well,
So-
I'm old. I could drop dead on you right here. That would probably like really boost your channel if an atheist dropped dead on your channel.
Oh, that would be crazy.
That would be cool, especially if I said, "Oh God," and clutched my heart.
Oh man, that would be. Yeah,
That'd
I
be
would
awesome.
getting. Yeah, we'd be getting.
3,000 subs in like overnight, man.
Yeah, that'd probably be a news story too.
You'd have to pay me for that.
Okay, I'll send you. It's actually the thing about the genes being in place was actually from it's from actually a theistic evolutionist. She's a what is she? She's a PhD in astronomy, I believe. And it was an article that someone had wrote on her website describing that, and it was critical of neo-Darwinism. It's just something I thought about bringing up. It took me a while to find it, though. That was what was annoying about it because I didn't remember the title. That was something I had to think about for a minute, and but yeah, I guess let's see. It's been about. Oh, go ahead.
Fire Back, is that the one? Fire Back, where the readers respond. What am I looking at?
Yeah, it was a post. It was a post on her website where someone had talked to give a response discussing Evo Devo.
Okay,
that's what I was reading from. It was hard. I was trying to quote as best I could. It is pretty long, and I didn't plan on doing that. So,
yeah.
But yeah, that'd be an interesting thing to read. All right. I guess it's been about an hour, so I guess we can wrap up in a few minutes. If there's anything else that you want to discuss or bring up, I guess we can talk about that real quick.
I'm good. I'm just I think I'm gonna have to create a video about this, but basically I was gonna poke at SFT, standing for truth, but I don't think I'll do that. I'll let him go.
Okay. I did want to ask maybe like one question before we wrap it up.
Sure.
Is that all right? What type of evidence would convince you that some intelligent entity was involved with life's conception or the universe's conception?
God, somebody that came up while I was watching Matt Dillahunty. They asked him what kind of evidence would convince him that God existed, and I think it was what did I come up with? It would be the same kind of evidence that I would have to have in order to believe that there are aliens. If like aliens, like UFOs are not evidence enough that there have been aliens visiting the Earth, I would actually have to see them on CNN. I'd have to see pictures of them. I'd have to see them interviewed, that sort of thing. That would convince me that there was some other thing. I am such a strict naturalist, a presuppositional naturalist, that I don't believe in anything. I don't believe in any kind of mind without brain, body, and world. And that is a whole nother discussion. But anyway,
Yeah, I mean, my view is that, like as Romans 1:20 states, it says that God can be seen through what He's made, and I believe that's or seen and understood through what He's made. I believe that is apparent, especially with what we're talking about with the microorganisms and genetics. And it says that people are without excuse. So I do believe that He can be seen through what He's made. So that's just my quick response to that.
Okay.
But yeah, I guess if that's all, I guess we're about done here. We've got a lot covered. So
I need to go watch Netflix now. So anyway.
okay, well, yeah, I'll go ahead and about to go off live or go
Okay.
in the broadcast. So everybody, this has been Creation Discussion 4, and hopefully I'll make another video soon. So thank you for tuning in, and God bless.
Good talk. Bye.